We're going to talk about how an electrical message that propagates down the presynaptic axon is converted to a chemical message at the axonal terminal to communicate information to the postsynaptic neuron. So the presynaptic cell gets excited because it's stimulated at threshold or above threshold. As a result of that, an action potential is propagated down the axon, and once it reaches the axonal terminal, and only when it reaches the axonal terminal, the calcium channels open up. Now, calcium is a cation or positively charged. When it enters the presynaptic terminals through the dedicated channels that now have opened up as a result of the action potential arriving at the axonal terminal, the vesicles that contain the neurotransmitter fuse with the presynaptic membrane and empty their neurotransmitters through a process called exocytosis. So exo means exit, cyte means cell, so exiting the cell. Now the neurotransmitter released in the synaptic cleft or the gap will really do nothing much to the postsynaptic cell unless it's able to attach and activate the postsynaptic receptor. Once it attaches to the postsynaptic receptor, it can have either an ionotropic effect on it, so a very fast localized effect, or a metabotropic effect, one that takes longer to activate but induces much more long-lasting intracellular changes. So in other words, the effect of the neurotransmitter will depend on what type of receptor it activates. And then it detaches, the neurotransmitter detaches from the receptor, but it can't just remain in the synaptic cleft. Otherwise, it will keep activating the receptor. Okay? So we have to get rid of this neurotransmitter, and there are a couple of methods to get rid of the neurotransmitter. One, you can have an enzyme that degrades the neurotransmitter into inactive parts, such as the example given here, the monoamine oxidase, which if you might have a monooxidase inhibitor or have seen one, which is an antidepressant that inhibits the enzyme that inhibits or inactivate neurotransmitters such as serotonin, dopamine, and norepinephrine, what's called the monoamine group. That's why the enzyme is called monoamine oxidase. So if you inhibit the enzyme that breaks down the neurotransmitter, you allow the neurotransmitter to remain in the synaptic cleft longer, or in other words, you increase the effect or the amount of neurotransmitter available in the synaptic cleft, and that would be called an agonist. Another method for inactivating the neurotransmitter is to recycle it back, or a process called reuptake, where all the neurotransmitter in the synaptic cleft can get recycled back through dedicated protein transporters on the presynaptic side that will recycle the neurotransmitter back. An example of this is serotonin. Serotonin is a neurotransmitter that gets inactivated by the process of reuptake. So SSRIs, selective serotonin reuptake inhibitors, inhibit the reuptake process, thus allowing more serotonin to remain in the synaptic cleft, and is used as an antidepressant.